you need to have in mind that actually the electrical industry and the energy industry are two very conservative industries. They are not used to changes very much. They need to have some kind of playground to manage these changes. I think that's change management is one of the core problems that we have at the moment.
European distribution grids are facing major challenges. An estimated 600 gigawatt of renewable energy, 50 million electric cars and 50 million heat pumps must be integrated into power grids by 2030. Which is technologically feasible, but the factors of time, money, resources and regulation also play a role in the solution. And occasionally there are side effects that need to be taken into account as well. So where and how is the best place to start? We'll find out in this episode. Welcome to the 𝗧𝗶𝗺𝗶𝗶 podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. Very much looking forward to talking to my guest for this episode, Dirk Kaisers. He has more than 15 years of experience in the field of renewable energy and energy storage and has led several high-profile projects in Europe or Africa. Currently, he is Distributed Energy Management Segment Leader for the electrical sector of EATON, responsible for Europe, the Middle East and Africa. EATON is a globally active intelligent power management company and involved in many sectors from power generation and distribution to the consumer. Welcome, Dirk.
Yes, hello, Zach. Thank you for having me.
Now, if we talk about the 24/7 renewable energy supply, there's two words that are super important, and that is flexibilization and digitalization of the electricity grid. So looking at that, what do you see as the most important technical and regulatory measures to achieve this, and how can we implement them at the same time as quickly as possible?
Yeah, that's a great question, Zach. So I think what is happening at the moment is that we see a major shift within the energy system from a centralized approach to a very much decentralized approach, meaning as you were saying before, there are millions of new assets coming into the play, millions of new electrical chargers, millions of heat pumps, million of energy storage systems, and these all can actually help to stabilize the electrical grid. And that is where the digitalization of the electrical grid comes in place as well. You do not have anymore the centralized automation system sitting within the electrical utility, but rather you have technologies that drive autonomously the millions of assets to a system benefit, I would say. And what we see at the moment is that from the technological point of view, this is all feasible. I mean, we are selling chargers, we are selling heat pumps, energy storage is deployed and everything. The thing that is missing and is lacking is actually the regulatory space. So we cannot use flexible assets as we should be for the benefit of the electrical grid. That is a major burden that we see at the moment.
And what exactly would fill the gap from a regulatory perspective?
I'm active a lot in the Brussels area with the policy makers over there as well, in Berlin, being native German. And what we do see is that there are reforms needed within the electricity market. So the Brussels arena actually set up some rules. They made quite some changes, especially to the electricity market, where the role of flexibility and demand-side response devices are more targeted and are now playing a central role in it. But the remuneration of these flexible assets is not yet set. And in a lot of markets, actually, there is no real market for these kind of assets. So that's kind of like a major problem that we do see.
Those are some necessary regulatory measures. Now, all these devices are out there. They're all being sold. You mentioned that digitalization is crucial. I just suppose they all have their different standards, different coding, different languages. So I assume regarding digitalization, there probably still has to be happening a lot of standardization or integration.
Yeah. I mean, like definitely that is very much true. Like one of the blocking points actually that we run into when deploying new technologies was, for example, privacy rights and then data ownership within the energy space. I mean, obviously, when you look at these assets, in order to manage them and to control them and to digitalize them, you need to create data, and therefore you need to use that data. So then the questions come up: who owns that data? Is this like the electrical utility? Is this like the provider of the technology? Is it the owner? And there you still see that there are some gaps because obviously in the European Union privacy is a very big thing and very important, rightfully. And that is something that we still need to resolve somehow. And there are some thoughts around it, but still that is like a very much open point, I would say. That's like one of the main blockers.
Hearing this, on the one hand, regulatory roadblocks, usually politics doesn't move that fast. On the other hand, who owns data? That's not a technical question. I guess it's more also a question of policy, but more like, of politics in the sense of like, which company makes the first step? Which company says, all right, let's do this, let's cooperate. Yeah. So two very tricky things. How can we solve them as quickly as possible?
Yeah, I think like what we need to do is to create, I would say, like some sandboxes when it goes into the implementation of digital solutions, because you need to have in mind that actually the electrical industry and the energy industry are two very conservative industries. They are not used to change this very much. I mean, like their business model was the same for the last 70 years, 100 years. And therefore now they are under a great stress when it comes to the digitalization, which is like one big changer, and the decentralization, as mentioned before, that's the second biggest threat to them. And therefore they need to have some kind of playground to manage these changes. I think like that's like change management is one of the core problems that we have at the moment.
All right. Change management. That's very interesting. So it really depends on changing the culture.
Yeah.
And that's very interesting because usually we talk about technology, we talk about regulation. We very rarely talk about change management and transformation management.
Yeah.
Quite interesting. Now, you mentioned decentralization so much, which means that decentralization actually pushes and I guess also increases the grid edge. So the interface between the grid and electricity producers and consumers. Now, on the one hand, that brings about challenges. On the other hand, probably opportunities. So diving into both, which opportunities and which challenges do you see at the grid edge?
I mean, like the opportunities definitely are that you can create new business models. I mean, like it's around monetarization, and I think with working on the grid edge as well, you in the end help to stabilize the grid. So that's a really good thing to do. And one of the threats actually is that the grid as it is now is not used to be managed that way. And for example, we do have a lot of substations in the grid that are more or less flying blind. So they're not monitored. They only have like the transformer and the switchgear sitting there. And when they break down, and nobody knows about it. So and then that is like some of the major problems that we do see, that the grid itself is not monitored, and rather on the grid edge itself, it is like really a black hole for most of the electrical utilities. So that's, I think, something that needs to come at the same time. So the digitalization and the modernization of the grid infrastructure itself.
Now, in regards to trends and technology being developed, particularly in that space, which ones are the most important in the next 5 to 10 years to solve these challenges?
I mean, like from EATON's point of view and from my point of view, definitely it is. We need to enable the substations. So smart substations for us is very important. You got hundreds of thousands of substations, and you need to enable them to participate actively into the grid.
So we're talking about retrofitting.
Yes, definitely. I mean, like, so last week I came across some new data from the European Union now with the commission, with the new commission being in place. Obviously, one of the main focus is the accelerated energy transition. And it became quite obvious that on one hand you have like the retrofit work due, which is like really heavy because like the grid is overaged. Most of the substations are more than 40 years old. So it's really old stuff that is out there. And on the same time, to integrate like the new technology, the new renewable energy, the new chargers and everything, you need to extend the grid at a pace which actually doubles the grid infrastructure within the next 15 years or so. So it's both. It's retrofit and it is new build.
So I see one of the most important things is to shed light into that black hole, as you mentioned, monitor substations, bringing intelligence into the grid edge. Now, of course, one of the biggest buzzwords everybody talks about at the moment is AI, particularly Gen AI, but one or the other, how big is the potential of it to improve grid control or energy management and make the grid more efficient and resilient?
Yeah, I mean, like obviously it's very big. The potential is definitely there. So we have a data research center in Dublin now for a couple of years, like with a lot of people working over there, and they're working on data analytics. And then there within the data analytics, obviously AI is one of the core methods to do this. So we are exploring like different fields to help actually the grid stability. So one thing that we developed is like an algorithm for electrical utilities that actually predicts upon the data provided from the electrical utility where electrical charging infrastructure is gonna be built. So it's a look into the future. And coming back to what I was saying before, that actually the pace of the grid modernization and grid infrastructure build is like very fast. You need to have like predictive models to do this. And for predictive modeling, obviously AI is the way to go.
People like me talk about AI because a lot actually is not AI, it's machine learning, some is algorithms, some is actual AI, and then Gen AI is a totally different thing. But if you really make that differentiation, is there already a place for Gen AI as we know it in energy management or in developing concepts? Or have you heard of cases of people leveraging Gen AI versus AI?
Yeah, I think so. I mean, like that's not like really my field, but when you look into the electricity markets and now like electricity markets in the European Union are changing from a fixed tariff to an hourly tariff, like where you actually can actively trade energy. And then energy trading is like a case for Gen AI. So that's for sure. And then going back to it, I mean, like we are creating as well virtual power plants, and then optimizing these assets within the virtual power plants as well, like is something that you can do with the AI. So yeah.
Now, to what extent does the solution become a problem in itself? Because, of course, we're talking about a massive increase in energy consumption and production. At the same time, AI, the more intelligent it is, usually the more energy it also consumes, particularly if you look into large language models, etc., and if you develop them. So how can we make better and more efficient use of the advantages of AI while not creating more problems?
I mean, like, indeed, it is a problem. So one of our big use case is actually that we are selling UPSs into data centers. So we are working very much with Microsoft and Amazon on that one. And they obviously have a huge demand in data centers, mainly due to the AI boom. So that is creating problems actually for the grid itself. So we see, for example, that in Amsterdam you cannot build any more data centers because the grid is too much congested. So they don't give any more grid connections to data centers because they suck too much energy out of the grid. This is creating a destabilization of the electrical grid. So that's, I think, like is a massive problem. On the other hand, if you look into the hyperscale data centers, the main IT companies are very much aware about this problematic, and then what, for example, they are trying to do is to shift then calculation resources like from one data center to another. For example, like if they have data centers in Norway sitting and then they see that there's a congestion in Amsterdam, they can change, say, their data operations, not instantly, but relatively near time from one data center to another one. So that itself could eventually become an asset to the electrical grid.
All right. Now, talking about solutions creating more problems, we switch from energy consumption to a sustainability perspective or a climate perspective. And some of the solutions that you already mentioned that are quite necessary for the energy transition are not that unproblematic themselves, particularly if you talk about fluorinated greenhouse gases that are necessary, for example, in wind turbines and heat pumps and transformer stations, or maybe not necessary, but quite common. Yeah. So maybe you can enlighten us a little bit more, because it's not common knowledge for everybody, I think.
Yeah, right. Absolutely, Zach. I mean, like that's like actually one of my favorite topics, I would say. So, I mean, like before joining EATON, I was working like for a long time within the photovoltaic sector, so doing like grid scale projects and stuff. And only when I get to EATON, I became aware about the problematic around SF6, and that is used within solar parks. Within the switchgears of those solar parks, and the SF6.
Before you continue, just SF6 is that name of that specific fluorinated greenhouse gas.
Right. Yeah. Sure. So yeah. It's that's the name, and actually it's the worst greenhouse gas that exists. It's man-made. It's, I think, like has an equivalent of CO2 of 23,000 something. So it stays in the atmosphere for like 3,200 years. So it's like really nasty stuff. And then building, solar parks or wind turbines with that greenhouse gas included, it does not make sense at all. And that is like where we as EATON campaign strongly. I mean, like we had the technology solution for more than 60 years in place, which use there, which is like fine, like it's a common technology that we are using. And so we campaigned in Brussels to ban actually SF6, and finally we had success, and then now the SF6 gas will be banned in switchgear in 2026 onwards. So that's, I think, like is a very good and strong sign for the environment that the European Union is doing.
The effect of SF6 is 23,000 times more critical or traumatic than normal CO2. That is, I mean, that's a huge number.
Yeah.
But what magnitude are we talking about with SF6 being out there in the field? Is it like 1% of a switchgear? Is it 99%? And how much in total?
Yeah, I think it was like state of the art. So I think like almost all switchgear used to have like SF6 because it had some chemical properties which were beneficial. I mean, like it used to be built into windows. It used to be pumped into shoes. Like it was like used also all over the place. And then only with the awareness around like the climate change and greenhouse gases, it was banned. And the switchgear was one of the last exemptions that there were. And the industry claimed that there weren't like any technology alternatives available, which was not true because we, as said, we provided it for 60 years.
And what's your alternative technically? What do you do different? Sorry, we really dive into nerdy details here. What do you actually need the SF6 for, and how did you solve that differently?
Yeah, I mean, like the SF6 prevents electrical arcs within the switchgear. And we use air to do this, which actually needs a slightly bigger version of the switchgear itself. But other than that, it is like the same principle.
And it just means you need to build the box slightly bigger.
Yes, exactly.
Okay.
Exactly.
That's such an easy fix, to be honest. Now, you mentioned that EATON has been using that technology for 60 years. And I think on your website read that it's actually 2 years ago you sold the 1 millionth unit with that kind of technology.
Yeah.
So one thing, that is quite a success. But at the same time, is it a huge failure that it took 60 years for the rest of the industry to use that technology as well? I mean, why does it take 60 years if it's such an easy fix?
Yeah, I think like that's like with all things that have to do with climate change and what I said before, like the change management. I think like the competition, they had like their technology. I mean, like they were selling their technology. Nobody actually, I think, cared about the SF6 story. So we were on it like obviously right from the start, kind of. And I know that before this round of the F-gas regulation revision, we as EATON were like the only company actually pushing for a ban. Like the other companies weren't ready yet. So, and I think like now they have developed like new technologies as well. And that is like where now the industry as a whole decided, or like we're positive for a ban.
Now, I think there's like a theme developing throughout our conversation, and to wrap it up, because I think what we hear here are two poles. On the one hand, the necessity for regulation, because as we heard, innovation itself is not changing an industry or a market. You also need regulatory pushes. On the other hand, people always seem to underestimate that it actually is a transformation that needs change management. Now, with EATON being active globally, what other models for a successful transformation do you see out there where those two poles are being bridged successfully that we could copy here in Europe?
Wow, I mean, like that's like a broad question, you know. I mean, like obviously we have a very strong presence in the US market. In the US market, the situation is slightly different. I think like, especially due to the nature of the electrical grid. I mean, like the country surface is much larger. They have much more overhead lines, so they are much more coping with wildlife fires and natural disasters, things that we do not have here. So the grid itself need to be much more strong over there. And on the other hand, we see, for example, in California, which is like a very dense populated market, they are kind of like going into the same direction that we in the European Union are going. So they are using the residential energy storage systems. They are much more emphasizing the need for the digitalization, obviously, talking about California. So and that is something I think like we can learn over here. So to actually embrace more new technologies. That is something that we need to do.
Thanks so much for joining me today, Dirk, and enlightening us specifically about intelligent grid management at the edge, and also about SF6 and why we do not need it anymore. Thanks a lot.
Yeah, all right. It was a pleasure.
You can find out more about this topic at Empower Europe, the international exhibition for energy management and integrated energy solutions. Empower Europe is taking place from May 7th to 9th, 2025 in Munich. You can find the latest news, interviews and studies online at em-power.eu.